Hello, everyone, and thank you for joining us for today's Fiber Broadband Association webinar. Today's webinar, Digital Fielding and Design, Field to Finish Faster, is presented by Magnasoft. I'm David Norris. I'm the webinar producer here at FBA. Before we begin, I have a couple of housekeeping items for you. So to make sure everybody has a good experience, I just want to remind everybody that you are in listen-only mode today as attendees. However, we will have Q&A at the end. So if you have questions, you can ask us those questions by typing them into the questions tool, which is located in the upper right-hand corner of your screen. Please do ask us any questions that you might have. We look forward to responding and sharing that with you at the end. Also, this webinar will be available on demand within 24 to 48 hours from the broadcast. You can access that on-demand recording of the webinar through our website under the resources tab. Do note that that is for FBA members only. So if you're part of a member organization, you'll need to, and you don't already have credentials for our website, you will need to get those credentials. But there's a link in the chat right now that'll help you do that. And so lastly, we do have a survey at the end, a one-question survey, so very quick, but we do appreciate the feedback. If you could take time to answer that, that would be very helpful. And so with that, I just want to welcome Mike McGill and Arun Kumar from Magnasoft. They're going to discuss mapping today, and what we're really going to be talking about here today is how developing accurate base maps and the utility pole data. It's essential for low-level design, but of course we all know that creating those base maps can be a really time-consuming and complex process, and that leads to cutting corners on design. However, we're at a stage now where we have remote sensing, AI, and other technologies that can really help us out to create high-quality, cost-effective base maps, and which include the utility pole data. And so I'm pleased to have Mike and Arun with us today. They're going to be sharing some of the key components necessary for delivering great base maps. Mike McGill is the Vice President of Market Development at Magnasoft. He's focused on telecommunications and electric utilities and markets in North America. Mike has conducted business in over 35 countries, and he's learned during that time that we have far more things in common than we have differences. And by blending roles in sales, business development, product management, he's further enhances Mike's geographic experience. All things spatial seem to be the common thread through Mike's 30 years of experience with companies like Autodesk. A big fan of Autodesk, by the way. Digital Globe, GDT, TomTom, and IKE GPS. He is the co-founder of Silent Falcon UAS, an emerging leader in applying GIS and AI to FAA runway condition assessment. And having studied international economics in college, Mike keenly observes global markets and is passionate about producing an optimal balance across local and offshore design teams. He's also a father of 4 young adults. Mike is actively involved in his local area in Boulder, Colorado, and working in small ways to impact the next generation and hopefully beyond. We're also joined by Arun Kumar, Vice President of Sales at Magnasoft. Arun is an experienced leader in sales and solutions with a deep understanding of technology and a demonstrated history of delivering results in telecommunications industry. He is very passionate about providing excellent value to customers by building relationships and exceeding expectations. With over 25 years of experience with service providers, OEMs, and engineering firms across the US and India, Arun has the ability to understand the customer pulse and create win-win situations for all stakeholders. So welcome, Arun and Mike. We are pleased to have you here. And with that, Arun, I will hand things over to you.
Thank you, David. Appreciate it. Hello, all. Welcome to this webinar. And if you can move to the next slide. All right, thank you. Thank you, David, and thank you, FBA, for the opportunity to provide this webinar on behalf of Magnasoft. Mike and I are super excited to talk to you about this. And the topic for today is digital fielding and design, field to finish faster. Excited to talk to you more about this, and of course, want to continue the conversations as well. If you're coming to Fiber Connect or Mountain Connect, we have a booth in both Fiber Connect and Mountain Connect. Would love to see you there and spend a lot more time to understand your needs, provide you with the best possible services we can on that. If you can go to the next slide, please. Thank you. Magnasoft, at Magnasoft, we have been doing over 23 years in telecom and utilities, and we've always been working on the front end of innovating and making sure that there is always success for our clients. And that has actually brought us to a great experience in terms of spatial data. If you can go to the next slide. We have always been all things spatial. Right from 2000, when the company was founded, the focus has always been on GIS, and we have actually used that expertise in GIS and harnessed that towards telecom, and we've been providing telecom services for a long time as well. If you
If
can
I
go to the next slide.
if I could add to that, Arun,
Yeah,
I joined
yeah, please.
Magnasoft. I joined Magnasoft 3 years ago, and one of the reasons why I joined Magnasoft is this expertise in spatial, and having that expertise over a 23-year period means we've seen it all from the foundational 2D mapping that we were doing when the company was started, all the way through to the more sophisticated digital twins that we're seeing today, and all of the things that go not just into spatial data management, but production, and having expertise in things like LiDAR and mapping and CAD and just all things spatial in general. And so I not to oversell it, but that was a real big reason why I joined Magnasoft, and that background has really served us well. And I think you'll see that come out in today's presentation.
Excellent, excellent. Thank you for that, Mike. I appreciate it. And talking about, what is it that we always think about when it comes to doing fiber designs? One of the biggest challenges we always see is there's huge delay from the day we decide that we want to do this to where we really start doing actual designs, right? And this is actually, we've seen it over and over again in many, many, many customers. And one of the biggest challenges is how do you get really good quality base maps, right? And it's just not an inconvenience overall. It really affects how the companies perform and able to do quality designs and follow through with quality deployments as well. And I'm sure Mike is itching to add a lot more to it. Go ahead, Mike, if you would like.
No, actually, that's it. Let's just. I think you have no
Yeah,
other. There
let's
we go.
focus on. Thank you, David, and team. The focus for today's webinar, of course, is digital fielding and design, right? And we have a complete umbrella suite called M-Fiber, and our focus is purely towards providing fiber services through this. And in this webinar, since digital fielding and design are two massive topics, our focus is going to be purely on digital fielding and how it's going to impact in project success with so much happening around in the industry and with big funding coming in and all of that. Our focus is going to be on digital fielding first, but we would love for you to join us on a follow-up session on digital design as well, which we'll be announcing soon. Yeah, if you can go to the next slide.
So before we jump into
Go
the
ahead.
core of the presentation, Arun, I thought it would be, and actually, there, somebody could mute their microphone. That would be good. Uh, I thought it would be good to start with a question that I saw a few weeks ago on IQGeo's webinar, a great webinar. And I thought this question would be relevant for the audience and just for us to get and share some feedback. So let's go ahead and go to that question.
What's your biggest current design challenge? That is, this is something that we always see, right? And we would love for you to answer these questions as input data quality, design speed, or design output quality. And thank you for voting. I see that it's already happening really fast, and we really appreciate it.
It's really cool to watch this interface on this side of the
I
presentation
know, right?
and watch this input come in real time. So thank you.
Yeah, this is a really nice tool for sure. This is a really nice tool for sure.
It looks
And
like we have.
as we see it grow. Oh, sorry, go ahead, David.
I was just going to say, it looks like we have a good number of votes in.
Yeah.
Absolutely, absolutely. It aligns exactly with. I would love to go ahead and announce the results as well. It aligns exactly with what we were talking about, input data quality, and that's the primary reason why we are having this webinar done, right? And once you have real good quality data or base maps available, you can always move to design and output very quickly. So thank you for this. And this was a great question that IQGeo asked, and we wanted to do the same and ask this. So yes, please. Mike, do you want to add something to it?
No, uh, the
Over
correlations, yeah,
50%.
very close, very close.
Yes, over 50% said design input quality. So perfect. Uh, Having said that, Mike, I would love for you to get started and talk about this a little bit more.
Yeah, so the first thing I wanted to do is just to kind of set this up. Hopefully I'll put the gray in my beard to to good use in today's webinar. One of the things I bring to the conversation is a unique balance of design software. David had mentioned AutoCAD, but also remote sensing, and remote sensing all the way from satellites in space to aircraft to drones to mobile lidar units and even handheld units on the ground. And so the perspective that I brought and I bring into Magnasoft is that coming into Magnasoft, something that was front and center for me was that the industry has a challenge with fielding resources. And not only is it hard, and it seems to me over the last 3 years, it's gotten harder to find skilled people to do the work. The interesting thing about fiber is you have shortage of labor, but you also have the transitory nature of going out and fielding these jobs and these projects, and it's moving people and equipment to the market when you need them. And so the combination of a shortage and the transitory nature is a real challenge. So then one of my next observations was, and again, this was at my previous work. If you could go to the next slide, please, David. In my previous work was the disparate nature between workflows for aerial design and underground design. And at the time, I was focused purely on aerial, and I was trying to provide a solution specifically for aerial design. And I noticed that in many cases, not all, but in many cases, there was not a strong correlation between the aerial design and the underground design. They seem to be separate workflows, and I always questioned that. And when I came into Magnasoft, I was thinking, okay, there's got to be a way to solve those disparate workflows. And then ultimately, one of the conclusions that I had was that there were many single point or people focusing on providing a solution through the narrow lens of a particular technology. But ultimately, when it comes to creating a base map, the conclusion that I had was there really is no magic bullet. And that was the perspective that I had coming into Magnasoft. Is that helpful, Arun?
Excellent. No, that's great. Yeah, absolutely. And the fact that you came in with that perspective and you've been here for about 3 years in Magnasoft and you've seen what's being done, how it's being done. Has your perspective changed at all, or what have you done over the last 3 years that has
Yeah.
kind of brought some change to it? There should be some, right?
Yeah, it kind of, yes. And if you don't mind bringing up the next slide, David, I hearken back, and this is probably my age thing, to former President Clinton and his phrase, I feel your pain, is as a service company and providing design services to customers, I have seen front and center the challenges associated when you're on the receiving end of base maps and you're reliant upon people providing you with good and reliable base maps, that data availability is a huge key. If you're expecting data to come in at a particular time because you've got a design team that's standing by, you need that data when you expect that data. And then when that data shows up, if there are elements that don't live up to the accuracy you're expecting, all of a sudden you have to say, stop the production line. We've got to go back and fix this. And all of these things have a cascading effect or consequences on design. there's an increased cost, there's an extended timeline, and quality issues just add cost. And the challenging thing is it's an unknown cost. It's hard. Actually, it's you quantify it, but you quantify it in the rear view mirror when you're trying to figure out what were our margins on this project
Where did we
exactly.
lose all the money, right?
So it has a huge impact. And so the reason I brought up the joke about feeling your pain is, I've seen that firsthand. And ultimately, the conclusion that I arrived at um, in Magnasoft is it really comes down to a conversation about total cost of production, which we're going to touch on today. But if you have varying degrees of efficiency, then you have varying degrees of cost, and that means you don't have complete control of time and cost, and that has an impact on the total cost of production.
Absolutely, absolutely. Thank you, Mike. And that actually brings up to the meat of what we really want to talk about today and how we want to make sure that it's efficient in things. Would love to ask a quick question, a polling question to the audience as to how are you really producing your base maps today? And would love your answers. And we'll talk about that and read out as well very quickly. There's no one certain answer for sure, right? And so would love to see what is your preferred choice so that we can talk about that a little bit more. I see the manual data collection leading the race, Mike.
Mm, yeah. Manual data collection and combination of the above. A little bit of aircraft
Yeah,
and
yeah,
drones.
yeah, yeah. It's between manual data collection and combination of the above is what is actually kind of leading. And mobile LiDAR doesn't seem to be doing much right now.
Yeah.
All right, we have
Yeah.
we have the poll. 44% voted on combination of the above, and manual data collection was 53%, and mobile lidar was 0, and aircrafts was 1. So it's great. Thank you, David, for running this poll. We appreciate it, and that actually brings us to the next segment of our conversation, right? Having learned over the years in terms of how telecom has been and how digital designs has been done, we really want to see what we can do to accelerate that pace and bring a solution to the market that will make it a lot more efficient. And that's what this solution is all about. And I'll hand it to Mike to talk about that solution a little bit more, Mike.
Yeah, so I'm going to spend a few minutes and I will try to do this succinctly, going into the 5 components of a digital fielding solution. Before I dive into this, I want to emphasize 2 things. What I'm presenting today is evolutionary. I'm not presenting something new that's in the marketplace. It's really an evolution of people, process, and technology, bringing those things together at the right time to bring a solution to market that not only solves a problem in terms of quality and accuracy and time, but also cost. Because ultimately, when you bring a solution to market, it can't be more expensive than the way people are used to doing things. Otherwise, they'll either reject it or it will just take longer for it to be adopted in the market. So one thing is this is evolutionary. The second thing is the challenge we all face in the marketplace is that in our estimates, if you just take the 100 million homes that need to be passed over the next several years and the BEAD funding and all of the money that's going into designing and building out fiber networks, our estimates, and we think this is conservative, but our estimates is that 275,000 miles a year will need to be designed over the next 5 years. 275,000 miles per year over the next 5 years.
And, and,
And a
and that's a
high
lot of
percent
driving.
and a high percentage of those miles will require very accurate base maps. Some areas won't. They're rural. They just, the attention to accuracy is not going to be as great. But in many areas, the attention to accuracy and time is going to be critical. So when you start thinking about those numbers, you realize that we need a very efficient solution to be on the front end of those design miles. And so the first component in our digital fielding solution is upfront having a design schema and understanding what data we can source that's publicly available. Currently we have a design schema that includes 45 different features, but with a customer, you always want to review that design schema because you're starting with the end in mind. What data are we going to extract and present in this base map? And it's critically important to have a design schema and then understand what data, like parcel data, can we leverage from publicly available sources that can go into the design. That then leads us to the second and very important component, but sometimes a component that people focus on too much. It's critically important, but I've seen, and this is part of my comment about evolution, is that people will look at mobile sensors and say, oh, this is the end all be all. We can do it with this sensor. We can do everything we need with this sensor. And what you'll see in a moment is, in our humble opinion, you can't do it with just the sensor alone. But one of the things that has become available in the marketplace and as part of our solution is access to high accuracy but lower cost sensors. The cost of sensors that combine LiDAR and 360-degree imagery, high resolution imagery, not only has the cost come down, but the mobility of those sensors has improved and increased. So a digital fielding solution requires access to high accuracy, in other words, highly suitable to the task, but lower cost sensors. And that is now available to us in the market. And fortunately, we've been testing a great sensor that serves this application. So then the next component is the mobilization model. Something I like to say is that if your high accuracy sensor doesn't have frequent flyer miles, then your mobilization model is not correct. The idea of having dedicated vehicles all wrapped with beautiful wrapping and all those things, and you're driving those from market to market is a missed opportunity. I can get a sensor to a market on Southwest Airlines faster than I can drive a Subaru. Test me, check me on that, but I think in most cases, I think that's correct. So a mobilization model is having an optimized mobilization model where you can move sensors from market to market, set them up, attach them to a rental car, drive the market, and then move the sensor to the next market is an important component to bringing down costs, but without sacrificing accuracy. So once you've done that and you've collected the data, you've collected it officially, we go to the next step, the next component, which is automated feature extraction. The popular term today is AI. Just with my background in remote sensing, I look at this and say, this is automated feature extraction, or call it AI, call it what you want. It's not new. What is new are the algorithms and the processing power that is available to us, especially in the cloud. And that's making the ability to automate the extraction of features from imagery and LiDAR much more viable today and much more cost effective. And then ultimately, that takes us to the final component, which is good old fashioned boots on the ground. So once we've extracted the features, and this is, in my humble opinion, where I think other solutions have got hung up, where they've said, okay, we're going to do everything with LiDAR. And they've discounted the importance of boots on the ground. Ultimately, you've got to ground truth this information, and you have to fill in missing components. But if we can get to a 70 to 80% base map through automated feature extraction, and then know what the gaps are that we have to fill with boots on the ground, we can load that information into a field data collection app. It's the little box you see on top of the data collector. If we can then ensure that the people who are collecting the data and completing the base map are very focused and they're highly targeted, so that if if in traditional field data collection modes, if you were able to collect, let's say a 2-person crew could collect 2 miles a day, I'm just making up that number, then we should, in this scenario, be able to at least collect 4 miles a day, 6 miles a day, or more, because the people are very focused, very targeted, and they're filling in the gaps. So ultimately, when you bring all of these things together, then this sensor and digital framework ultimately leads to consistent quality and optimized total cost of production.
Great. Thank you, Mike. This is wonderful, right? And then conceptually, this is perfect combination of having the really good quality sensors, that having the schema right, making sure that these sensors can be transported quickly, pulling in AI to make sure there is efficiencies included there, and then having the targeted feeling. So it's conceptually, we've spoken about that. Would love to move into some of the how it really flows and visualize what we produce as an output of
Well,
this.
let's
If you can go to the
visualize it.
next slide.
Let's visualize it.
Love it. Beautiful. So when you talk about base maps, right, typically what we all think about is a top-down approach in terms of what we see on the screen, for example. I agree that is something that's important. There is no doubts about it. But if you can go to the next slide, the actual uh, engineer, if an engineer is wanting to do something, they would want to see it from the ground up. They really want to see how it's looking on the field so that they get to see what's happening, what is on the pavement, what is there in terms of other equipment that's there, all the huts, all of that they really want to see. If you can go to the next slide.
And if I
And
and
so this is
actually if I
something
could
that's
com
important.
if I could comment on that, Arun, just for a moment,
Yeah,
because
yeah,
I think it's an important distinction, because this is something we've
yeah.
looked at quite a bit, because we've looked at being able to create base maps from an aerial perspective, but also from a ground up perspective. And our conclusion is
Yeah,
that people see these assets from the ground up.
they
And
do. Yeah.
that is the way logically to be able to map the information that goes into a base map. And that is a distinction. We are saying if we're going to use remote sensing, we believe that mobile LiDAR is the right core digital approach to doing the mass data collection. And so, pardon me for interrupting, but I just wanted to underscore that point.
No, that's a very valid point, and thank you for doing that. I really appreciate that. Right. Having said that, right, there are three things that we would like to see in terms of a good base map. Right. We should be able to view it from a CAD or any other GIS platform. Right. And that is very important. And the second one, of course, is the top-down view is extremely important as well. And then a 3D digital twin view. This is ideally the best combination that you could have. When you're able to see it as a digital twin, to see exactly what's there, and then able to see the base map from a top-down perspective, and be able to load it in a GIS or a CAD platform, and able to see the base map. This will enable the engineers to be able to see exactly what's there, do the right things in terms of design. And the biggest advantage on top of all of this is, of course, the permitting teams or the permitting organizations will look at what is needed in the format that they've prescribed. But one of the things that we see a lot of value in is to be able to add a link where they can click on it and they can virtually walk to the site to be able to see exactly what we have engineered on and asking for permits. And that's a
And
big distinction. Yes, go ahead, Mike.
yeah, if it could just comment,
Yeah,
this what we're
please,
looking at is
please.
a pretty picture, of a digital twin. But what I wanted to point out is that these are actual models that were all created from the sample imagery and LiDAR that was collected as part of this project. So we're not just piecing together a base map here and a real world view here and then a digital twin here. This is an example of real data
The actual
from
outputs.
yeah, and more we view things in 3D. And to be able to have a traditional 2D view in CAD or GIS and then a real world view, but also have the digital twins, and it doesn't cost more, yeah, why not?
And the best part about this is this, right? We're going to have so many things happening thanks to BEAD funding and the matching grants that are coming up and all that. There's going to be so much engineering work to be done, so much design work to be done, that there is not going to be enough time for the engineers that are out there to do these designs. Number one. Number two, if you're churning out so many designs, the permitting teams in different counties and organizations are going to have so much difficulty in checking some things if they have to send somebody out. And this is an advantage in terms of having the digital print so that they can just literally visually walk in and see what's going on before they approve so that they can avoid walkouts onto the field, right?
Yeah.
Back to you, Mike.
Yeah. And so what we've shown and what we've talked about is producing high accuracy, consistent accuracy. So and when I say high accuracy, for example, these base maps are accurate within 2 inches or better, both horizontally or vertically. That's an example of accuracy, being able to view things using 60 megapixel cameras. So it's producing high quality results, accurate results that you can view in 2D, real world, and as digital twins. But then when you look at the advantage that you're talking about, you then start to realize that having access to this level of information actually, and we're seeing examples of this in the marketplace, where providing access to things like an immersive 360-degree panoramic imagery and digital twins, and providing a virtual walkout experience, which is what you were talking about, Arun, that actually starts to help accelerate permitting. And not only does it help accelerate that because people are going to the field less, but as the people who are approving permits begin to have trust in the data that they're seeing, well, then that has a natural human effect on people's willingness and ability to approve things just simply because they trust the data. And so,
And if a
um,
permitting agency doesn't have to get in a car and go check something personally to make sure they permit it, they'll be more than happy to do that virtually.
they will, but let's not discount the fact that there are some people that just like to go out in the field. There's nothing we're going to do to stop that, but at least this creates an opportunity where you can present a traditional permit PDF, like you're used to submitting a permit exactly the way that they expect to see it. But let's put a
And
hyperlink in
just a
there,
clickable link.
little hyperlink
Just a
in there that
clickable
all of a
link.
sudden, yeah, that's okay. By the way, you can click on that link and it'll take you to um, a more detailed view that we think will give you confidence in approving the permit that we are submitting. So David, if you don't mind going to the next slide, because we need to start bringing this home, as they say. Ultimately, the solution that we're talking about and presenting today helps our customers optimize the total cost of production for their base maps through this digital fielding approach. And we do that by minimizing delays, errors, and revisits, so that we just have more control over efficiency and therefore more control over costs. And then ultimately what that leads us to is the next slide. Is the very simple proposition that and or what I would propose is that this digital fielding approach equals a better base map, and a better base map defined by having access to information that is accurate, access to information that is traditionally in 2D but is also available to you in the real world, and available to you as a digital twin. And that leads to better control over time and cost. And so I'll demonstrate my age. I'll give you a Dale Carnegie proposition. If I could show you a way to get better information, and it gives you more control over time and cost, and it doesn't cost you more, would you be interested in that? So pardon me for wearing my
You applying for a
pardon,
job in QVC, Mike?
yeah,
Are
yeah,
you applying
pardon
for
me
a
for,
job in
yeah,
QVC?
that's right, that's right. We have operators standing by, and pardon me for wearing my sales hat for a moment, but it really is that simple. It really is that simple. It's a better approach to getting better data that then feeds your design, the design process, and when you have consistency, then you can get through design faster and more efficiently. So with that, I will be quiet and hand it back to you, Arun.
Great. And of course, we would love to talk to you more about this. You can reach us at digitalfielding@magnasoft.com. It'll come to us, and we will definitely be sure to get back to you as quickly as possible. Would love to set up some time with you if you're attending Fiber Connect or Mountain Connect. We are going to be there. Me, Mike, our colleagues are going to be there as well, and would love to spend more time with you. And we have a booth there. The booth numbers are in the presentation, and I'm sure it'll come out in the emails as well. Would love to set up some time specifically to talk about the solution and what we can do. And Mike has already shared that in the chat box as well. Thank you, Mike. And love to talk to you more about this. And is it a good time to open up for questions, David?
Absolutely, and we do have a few questions that have come in here, and so we can go ahead and kick things
Excellent.
off. I think this is a good place to start. People are asking if the data from your solution, if that will line up with Google Earth and Google Maps imagery, which we're all pretty familiar with.
Yeah. Do you mind if I field that, Arun?
Hey, please do, please do. I know
Because
you're very passionate about that. Yeah.
well, look, I think this goes back to something I said earlier in the presentation, where we're clearly taking a foundational position towards mobile LiDAR as the core sensor. And once you make that decision, your accuracy is going to be, you're going to have relative accuracy within your base map based on your collection method. And what that means is that, yes, you can overlay the base map with something like Google Earth, but it's not going to line up. And if the requirement is to line this up with Google Earth, then I'm not sure what to tell you, because you're using imagery that has unknown accuracy. And so it will overlay, absolutely, but our goal is to make sure that we can present a base map that's viewable in the ways that we discussed, and not meant to line up perfectly with publicly available data like Google Earth or Google Maps.
Great, and makes sense as well with the you don't know what the timing is of the imagery that you're looking at, and some other things there too. So
Yeah.
let's see here. So the next question we have is, what is the typical turnaround time? And they give for a 50-mile project.
I'll feel that, Mike. I had a meeting in the morning today with a customer, and it was on a different project, completely different thing, but it takes about 48 hours for us to do any turnaround times. And the immediate question from the customer was, "Can you do it in about 2.5 hours?" And you're like, "Sure, I would love to do that," but that's, so I just thought I'll relate that. But typically, once we have the schema available, the exact expectation from the customer set, things like that, for about 30 to 50-mile project, we are thinking that within 3 to 4 weeks, we'll be able to give you a complete output that you're expecting. And this is when we say we're all done, we're ready to get started, and then hit the start button, and then 3.5, 4 weeks later, you will have the delivered output. That's what we're working towards right now. We have done some trials already, and it's been very successful, and we are very comfortable doing that. Mike, you
And
want to add anything to it?
yeah, I'll just add to that. Our goal here is that we get this down to a level of simplicity where you schedule it, and make it easy to book, and the availability of sensors is not the long pole in the tent. Sensors are available, and it's infinitely scalable. And that's
Yeah.
part of the low cost nature of the sensors. So that as demand goes up, so does the supply of sensors. And given the mobility model, and given the efficiency of boots on the ground, then this becomes something that can be very responsive, and something that can be delivered on a very timely basis.
That actually leads to another question that we have here, which is how your approach to sensor deployment differs from what others offer, and what the benefits are of that approach.
Yeah.
Mike, do you want to take that, or I can
Yeah,
either way?
yeah, because it kind of picks up on what I was saying, and I won't belabor the point, but I think it's different just because when I go to trade shows, I see, wrapped cars and sensors and stuff on top of those cars, and what I've seen historically are people are there's a 1-to-1 ratio of sensors to cars. Well, I guess that's true regardless, but they're dedicated to the car, and I think this approach of mobilizing them in a more efficient manner is the next phase, and I think we're on the early stage of that next phase.
All right.
And I want
Go ahead.
to kind of
Sorry.
expand a little bit more, David, on what Mike said, right?
Sure.
Mobility of the sensors, we have brought it down to where we are able to, move the sensor, as he rightly said, put it on a Southwest and get it there in 5 hours, and then get started with the actual work in less than 2 hours. So you go rent a car, put it on top, and then get started with it. That is how simplified the solution is, and that's, I think, a big advantage for us to take it to time to market.
And in the industry of full disclosure, both Arun and I are getting miles from Southwest by mentioning them.
No, I don't, but American, yes.
Yeah,
I'm from Dallas, so obviously it's going to be American, right?
yeah.
Thank you, David.
Sure. So moving on here, we've got what challenges do you typically encounter when integrating data from various sources, and how do you overcome them to ensure high quality output?
Great. I think, Mike, you're very close to it. It's close to your heart, so I would love for you to field it.
Yeah, the biggest challenge we're running into at the moment, and it's a challenge that we overcome, but when you get into integrating utility pole data as an example, because when you have to send boots on the ground, using LiDAR for at that level is still somewhat cost prohibitive, and therefore we end up using something like Catapult, which I think is a great solution to collect pole information. And so that data may show up in the base map differently, not in the same way that a pole shows up where we were able to collect it with the mobile LiDAR. But ultimately, that all gets adjudicated because it's going to show up in a pole loading application in exactly the same way. It is going to be represented in CAD in the same way, especially as we start utilizing things like 3D CAD using the map extension within AutoCAD. That all gets adjudicated in the final data set. In the base map, there still is a little bit of a challenge in how that information gets represented, but it's not a barrier to ultimately feeding in the data we need into the design process.
And that actually relates to another question too. I don't know if you want to expand on that, but that question was really about integrating data from various sources. But somebody is specifically asking about, how do you see the 3D digital field data being integrated within the design systems?
Yeah, that's great. I see it being integrated in things like using AutoCAD Map, or it's now referred to as a map extension of AutoCAD. And it really is going back to something I said earlier, where there has, in many cases, been disparate workflows between aerial and underground. If you take a holistic approach and you end up with a design that allows you to view things 2D, but also 3D, and then start to deal with things like adding strands to poles in that environment because you're operating in a 3D environment, it just makes things more efficient. And it gives you flexibility if you decide that you need to change your ratio of aerial to underground because the pole owner is being obstinate and, and making it prohibitive to attach to poles. Well, you've got all the baseline data you need to make that change without having to send people to the field again, um, or minimizing having to send people to the field again.
So you mentioned the sensors on the cars, and you know, in rule settings, somebody is asking a question saying, basically, in rule settings where the poles are not visible to the road, you know, how does this work?
Yeah, that's an
I
example of,
think
you know, yeah, go ahead, Arun. Go ahead.
Go ahead,
Go ahead.
Mike. No, okay, thank you. So that's one example where if you go back to the five things the five pillars that we talked about, the final pillar being the manual fielding, I think that's a very, very important component. And that's something that we really need to care for as well. And this is extremely mobile in terms of the sensors. So we can literally walk around as well with it. But more importantly, that's where the fifth pillar of having a manual data collection as well being available becomes a key element for the entire thing. Mike,
Yeah,
if you want to add something, please.
yeah. That's the 70 to 80% that I talked about earlier. You're going to get 70, roughly speaking, 70 to 80% of what you need when you drive the market, and then the remaining 30 to 20% is collected with boots on the ground.
All right. It looks like we have another question in the queue, but somebody raised their hand as well. If you have a question, if you could please type that into the question box, that would be helpful for us. But the next question here is, can you elaborate on the scalability of your solution? How can clients with large-scale projects ensure consistency and accuracy across all of their sites?
Excellent. Mike, do you want me to take that, or you can?
Yeah, I'll jump in. I think I already touched on this, but
You did, yeah, you did.
yeah, it gives me an opportunity to underscore the point. The sensors are highly available, and given the company that we're partnering with, we have the ability to scale those, and that the combination of the sensors and the automated feature extraction, the fact that it gives us 70 to 80% of what we need, and that we're able to really optimize the boots on the ground, then it makes the exercise of predicting time, it gives us a lot of control over that. So obviously a bigger market requires more time, but it can be minimized because you simply throw more people at it on the end part of the process. And it may take a few extra days to collect it using the mobile LiDAR, but we're seeing anywhere between 50 to 100 miles a day of collection rates. So when you add those things together, you realize that the solution really is highly scalable. I don't want to say infinitely scalable, but highly scalable.
And to add to that, the quality of base maps, I think, will enable the walkouts to minimize the walkouts as much as possible as well. I think that will be a massive saver as well in terms of time and efficiency, improved efficiency, if you will.
Absolutely. Well, I think that that's all we have coming in here at the moment. But with that, I just want to thank Magnasoft once again, and Mike and Arun for a great presentation, and sharing sharing not only the resources that you provide, but just general guidance too about how we can improve the digital field and design.
And if I may, David,
Sure, absolutely.
I would just like to say, first of all, thank you for hosting the webinar. And if there's anyone on the webinar today that's thinking about joining FBA, this is an unsolicited commercial. We've been Premier members for 2 years now and have received an incredible amount of value from being a member of FBA. So if you're thinking about joining, I highly recommend you do.
Well, thank you very much, Mike. We appreciate that, of course, and I'll get my checkbook right away. But just kidding, of course. We certainly appreciate that. We're glad you found value, and certainly, if you are not already a member, but you wish to become a member or to learn more, reach out. You can do that through even the webinars alias. We're a pretty small team here that keeps things going, so we can make sure you get to the membership team in the right place. But thank you for that feedback.
David, working with you was so awesome. You made us feel as if you have a 100-member team supporting you in the background.
Well, great. Thank you so much. And with that, I just want to thank you both again and thank everybody for joining us today. Really appreciate your time joining these webinars as you do. And we have many more coming up. Before we do, I'm just going to skip ahead here. We've plugged it a few times during this one, so there's not really too much need here. But if you haven't already registered for Fiber Connect 24, it's coming up quickly at the end of July. Great show. Everybody has a really good time. It's in Nashville this year, so we've got some great music acts and some other things lined up, and of course the opportunity to network with other people in the industry and to join some of the many exciting sessions that we have in store. So please do take some time to meet us at Fiber Connect. We look forward to seeing you there. And also, if you can make it to our regional workshops, we have a few more coming up this year. We're being in Des Moines, Iowa in September, and we're doing our first one this year in Calgary in Canada. So we're excited about that. That'll be in October. And then we'll round out the year in Albuquerque, New Mexico. So if you're in those areas or even not in those areas, put them on your calendar and come and see us at those smaller, more localized shows. We certainly look forward to seeing you there as well. And with that, I will just close again, inviting you to participate in future webinars, and especially our Fiber for Breakfast, which happens every Wednesday morning, and of course features Gary Bolton, our CEO and president. That's a 30-minute webinar series, and always exciting and has good content there. So please do join us. And once again, thank you everybody for attending, and we hope to see you on the next one. And I'll close things up.
Thank you. Thank you.
Thank you all. Thank you, David. Thank you all.
All right. Bye-bye.
Bye.